Next, we will look at some examples of web services. The first example will come from the exercises of this course. In the exercises you will do trend mining. The data for this trend mining has to come from somewhere. For the exercises, the data comes from 3 different sources. First, we have the API Stack Exchange that runs sites like Stack Overflow. Second, we have Scopus. This is an academic database run by Elsevier. And finally, we have Twitter that also offers an API to search and investigate their tweets. With API, I mean the web service interface that is used when interacting with the web service. As you can see, Twitter API has some limitations, but they are bypassed by this get all tweets scripts provided by Jefferson Henrique. Next, I will illustrate the differences between a web service and a web application using Scopus, that is Elsevier, web service and web application. From my browser, you can see that I have 2 tabs open. The one that I'm currently in is in GitHub. This is trendmining/getscopusdata.r. It is the same file that you will be given in the exercises. In the other tab, you can see the Scopus. This is the web application side. This is the graphical user interface that is used to search information in Scopus web application, whereas this script accesses the Scopus web service. Now I will explain what happens when we access Scopus web service. Basically, we want to execute some type of query in the web service to get data for our trend mining purposes. You can see that in the web browser, we are constructing a query string. We start by putting in continuous integration. This is our search term of interest. However, we cannot directly pass the search term continuous integration to the Scopus web service. We have to explicitly tell to which fields should the search be targeted for. Therefore, we here set the search to title, abstract and keywords. Then in the next line, we paste together title, abstract, keywords, which is the target, and the query string variable, which is continuous integration, as you can see from the line 21. Now, to illustrate how this is done on the web application side, I will do the same thing in there. So I pick up the continuous integration search string, copy to the board. I paste it here. Now we can see that the continuous integration search term is ready. And now I still have to check that I'm searching for the correct search fields. And it is article, title, abstract, and keywords, which means the same as title, abs, key that is set in here. Now all I do in the web application is execute the search, and I will get the results. However, now I notice that I get too many results. It is 21,000, which is clearly too much. And I realize that as I'm searching continuous and integration, they are considered as separate search terms. So I have to put them to quotes to get the correct amount of hits. As I'm interested in the continuous integration, both words appearing one before the other. Okay, as you can see, I now got 890 results from Scopus. However, as some of you may notice, creating the query string in the web service side is not yet complete. So what happens in line 33 is that on top of my query string that now contains title abstract keywords and continuous integration, we add another search term and all software testing. I will now show how this can be added on the web application side. So I will copy the software testing, copy this back here. I will add another search field, and here I will put in software testing, as you can see. And now from the drop-down menu I select all fields. As you can see, we have this and all here. That means the same, the and all here means the same thing as all fields in here. And now I execute the query. In the web application side, we get the results as a web page. In the web service side, we will get them by executing the function getScopusPapers with the variable myQueryString. We would get the results in variable called myArticles. So basically everything that can be done on the Scopus web application can also be done programmatically on the Scopus web service. Doing it programmatically on the Scopus web service has the additional benefit that we can immediately start further processing with our trend mining scripts instead of having to rely on web scraping or downloading data from the Scopus web application interface. Of course, in the web service side, things are not as straightforward as that we could just call this function getScopusPapers with our query string. What has need to be taken place is that someone has actually written this function, which can be seen here, getScopusPapers, that takes in the query string that fetches the data through the web service interface. You can see that this function is roughly starting from the line 26 and ending in line 89. So there is about 60 lines of code in here that actually grabs the data and stores them back so that they can be easily used. I have just demonstrated how can the Scopus web service and web application be used to achieve the same thing. I could have as well used the Stack Overflow or the Twitter web application and web service. Typically, both the web application and the web service offer the same features. However, the distinguishing difference is that one is used by humans and the other is used programmatically by software. Next, you should look at this example video from YouTube. The YouTube video describes a web service that is implemented as a REST API. Please be aware that REST API is just one way of implementing web service. There are other implementation technologies available, such as the SOAP. The link for this video is also provided in the course materials.